When designing the electrical system for a recreational vehicle park, begin by thoroughly understanding and adhering to the requirements outlined in National Electrical Code Article 551. This article provides specific guidelines for recreational vehicle parks and campgrounds, ensuring safety and compliance. Carefully plan the layout of the park, including the location of electrical pedestals, transformer vaults, and distribution lines. Optimize this layout for both efficiency and safety, minimizing voltage drop and potential hazards. Consider installing individual meters for each RV site to accurately monitor and bill for electricity consumption. This allows for fair and transparent billing practices. Ensure proper grounding of all electrical components throughout the park. Grounding is crucial for safety as it provides a path for fault current to flow, minimizing the risk of electric shock. Utilize appropriate circuit breakers or fuses to protect against overloads and short circuits. These protective devices are essential for preventing damage to equipment and ensuring the safety of occupants. When selecting parts and equipment, consider suppliers that operate in the Midwest region. For electrical pedestals, explore options from suppliers like Voltaire, Progressive Industries, or Versicon. These companies offer a range of pedestals designed for RV park applications. For metering devices, consider companies like Census, Itron, or Landis+Ger. These companies specialize in providing accurate and reliable metering solutions. When selecting circuit breakers, Square D, Eaton, or Siemens offer a wide range of options. These companies are well known for their quality and reliability. For distribution panels, contact manufacturers such as Siemens, General Electric, or Square D. These companies can provide distribution panels that meet the specific needs of the RV park. When sourcing transformers, check with suppliers like Cooper Power Systems or Eaton. These companies offer a variety of transformer options to meet different voltage and capacity requirements. For conduit and fittings, choose from companies like Legrand, Cooper Industries, or Allied Molded Product. These companies offer a wide selection of conduit and fittings to protect electrical wiring. When developing wiring plans, consider the power requirement of the RV sites. For RV sites with 30 amp service, use a 3-wire, 120/240 volts wiring configuration. This configuration provides adequate power for most RV. For RV sites with 50 amp service, consider a 3-phase, 120/208 volts wiring configuration. This configuration provides more power for larger RV with higher electrical demands. Run electrical conductors from the distribution panel to each pedestal using appropriate conduit and fittings. Ensure that the conduit is properly sized and installed to protect the conductors from damage. Connect the electrical lines from the pedestal to the RV electrical system. Follow all applicable codes and standards when making these connections. Provide a dedicated grounding rod or electrode at each RV site. Connect all electrical equipment to this grounding electrode to ensure proper grounding. The National Electrical Code Article 551 covers electrical installations in RV parks and recreational vehicle areas. This article outlines the specific requirements for wiring, grounding, and overcurrent protection in these locations. It's crucial to adhere to these requirements to ensure the safety of park residents and prevent electrical hazard. Firstly, 551.1 Scope. This article covers electrical systems for recreational vehicles and recreational vehicle parks. It specifically addresses the wiring methods, overcurrent protection, and grounding requirements to ensure safety in these unique environments. Secondly, 551.2 Definitions. Understanding the definitions provided in this section is crucial. These definitions clarify terms like recreational vehicle site, and recreational vehicle park, ensuring consistent interpretation and application of the code. Thirdly, 551.4 General Requirements. This section outlines the general electrical requirements for RV parks, including voltage limitations, wiring methods, and equipment installation. It emphasizes the importance of using approved materials and following manufacturer's instructions. Fourthly, 551.10 Grounding. Proper grounding is paramount in RV parks to protect against electrical shock. This section details the grounding requirements for RV sites, and the park's electrical system, ensuring a low impedance path for fault currents. Fifthly, 551.12 wiring methods. This section specifies the acceptable wiring methods for RV parks, including the types of cables, conduits, and enclosures that can be used. It emphasizes the importance of protecting wiring from physical damage and environmental factors. Sixthly, 551.40 recreational vehicle site supply equipment. This section focuses on the electrical equipment installed at each RV site, such as power outlets, disconnecting means, and overcurrent protection devices. It ensures that each site has adequate and safe electrical supply for RV. Seventhly, 551.46 overcurrent protection. Overcurrent protection devices, like circuit breakers and fuses, are essential for preventing overloads and short circuits. This section specifies the required overcurrent protection for RV sites in the park's electrical system. Eighthly, 551.47 receptacles. This section outlines the requirements for receptacles used at RV sites, including their type, rating, and installation. It ensures that receptacles are compatible with RV plugs and provide a safe and reliable electrical connection. Ninthly, 551.71 type receptacles. This section dictates the types of receptacles allowed for different amperage services, ensuring compatibility between the RV and the power source. It specifies configurations for 20 amps, 30 amps, and 50 amps services, promoting safety and preventing mismatches. Tenthly, 551.72 one location of outdoor receptacles. The placement of outdoor receptacles is crucial for safety and accessibility. This section mandates that receptacles be readily accessible and protected from the weather, preventing hazards and ensuring convenient use. When designing the electrical system for an RV park, several key considerations must be addressed to ensure safety, reliability, and compliance with electrical codes and standards. These considerations encompass various aspects of the electrical infrastructure, from the initial design phase to the selection of appropriate equipment and wiring methods. 1. Load calculation. Accurately calculating the electrical load is fundamental. Determine the total demand based on the number and type of RV sites, considering the potential for simultaneous usage of electrical appliances and equipment within the RV. This calculation informs the sizing of transformers, distribution panels, and service entrance equipment. 2. Voltage drop. Minimize voltage drop to ensure that each RV site receives adequate voltage under load. Excessive voltage drop can lead to inefficient operation of electrical equipment and potential damage. Properly size conductors and keep circuit lengths within acceptable limits to mitigate voltage drop. 3. Grounding and bonding. Implement a robust grounding and bonding system to provide a low impedance path for fault currents, minimizing the risk of electrical shock. Ground all non-current carrying metal parts of the electrical system, including pedestals, enclosures, and equipment. Bond metal water pipes and other conductive materials to the grounding system. 4. Overcurrent protection. Use appropriately sized circuit breakers or fuses to protect against overloads and short circuits. Coordinate the overcurrent protection devices to ensure selective tripping, minimizing the extent of outages in the event of a fault. 5. Surge protection. Install surge protective devices at the service entrance and at individual RV sites to protect against voltage surges caused by lightning strikes or other transient events. Surges can damage sensitive electronic equipment within RV. 6. Wiring methods. Select wiring methods that are suitable for the environment and comply with the National Electrical Code. Use underground wiring for distribution circuits to minimize exposure to weather and physical damage. Protect conductors from abrasion and corrosion. 7. Pedestals. Choose electrical pedestals that are specifically designed for RV park applications. Pedestals should be weatherproof, durable, and equipped with the appropriate receptacles and overcurrent protection devices. 8. Metering. Consider installing individual meters for each RV site to accurately measure electricity consumption. This allows for fair and transparent billing practices. 9. Signage. Provide clear and conspicuous signage to identify electrical equipment and warn of potential hazards. Label all circuit breakers, disconnects, and other electrical components. 10. Emergency disconnects. Install emergency disconnects at strategic locations throughout the park to allow for quick and safe energization of the electrical system in the event of an emergency. When designing an RV park electrical system, adhering to NEC Article 551 is paramount, but several common pitfalls can lead to safety hazards and code violations. Avoiding these mistakes ensures a safe and reliable electrical infrastructure for the RV park. One pitfall is inadequate load calculation. Underestimating the electrical load can result in undersized transformers, distribution panels, and conductors, leading to overloaded circuits, voltage drop, and potential equipment failure. Overestimating the load can lead to unnecessary expense. Accurately assess the demand based on the number and type of RV sites, considering the potential for simultaneous usage of electrical appliances. Another pitfall is improper grounding and bonding. A poorly designed or improperly installed grounding system can increase the risk of electrical shock. Ensure that all non-current carrying metal parts are properly grounded and bonded to provide a low impedance path for fault currents. A third pitfall is insufficient overcurrent protection. Using undersized circuit breakers or fuses, or failing to coordinate overcurrent protection devices can lead to equipment damage and potential fire hazards. Select appropriately sized overcurrent protection devices and ensure that they are properly coordinated to provide selective tripping. A fourth pitfall is neglecting surge protection. Failing to install surge protective devices can leave sensitive electronic equipment vulnerable to damage from voltage surges. Install surge protective devices at the service entrance and at individual RV sites. A fifth pitfall is using improper wiring methods. Using wiring methods that are not suitable for the environment or that do not comply with the National Electrical Code can lead to premature failure and safety hazards. Use underground wiring for distribution circuits. Protect conductors from abrasion and corrosion. A sixth pitfall is substandard electrical pedestals. Choosing electrical pedestals that are not designed for RV park applications or that are of poor quality can result in premature failure and safety hazards. Pedestals should be weatherproof, durable, and equipped with the appropriate receptacles and overcurrent protection devices. A seventh pitfall is neglecting signage. Failing to provide clear and conspicuous signage can create confusion and increase the risk of accidents. Label all circuit breakers, disconnects, and other electrical components. Warn of potential hazards. An eighth pitfall is lack of emergency disconnects. Failing to install emergency disconnects can hinder the ability to quickly de-energize the electrical system in the event of an emergency. Install emergency disconnects at strategic locations. Another pitfall is ignoring future expansion. Failing to plan for future expansion can result in costly and disruptive upgrades down the road. Design the electrical system with sufficient capacity to accommodate future growth. Finally, a pitfall is inadequate inspection and maintenance. Failing to regularly inspect and maintain the electrical system can lead to undetected problems and potential hazards. Implement a routine inspection and maintenance program to identify and address potential issues before they become major problems. Here are some best practices for RV park electrical wiring to promote safety, reliability, and compliance with codes and standards. 1. Planning and design. Begin with a thorough planning and design phase. Accurately calculate the electrical load, considering future expansion. Develop detailed wiring diagrams and specifications. 2. Use qualified personnel. Engage licensed electricians with experience in RV park electrical systems to perform the installation work. Ensure that all personnel are properly trained and qualified. 3. Adhere to NEC Article 551. Strictly adhere to the requirements outlined in NEC Article 551 for recreational vehicle parks and campgrounds. Pay close attention to grounding, overcurrent protection, and wiring methods. 4. Grounding and bonding. Implement a robust grounding and bonding system. Ground all non-current carrying metal parts. Bond metal water pipes and other conductive materials. 5. Overcurrent protection. Use appropriately sized circuit breakers or fuses. Coordinate the overcurrent protection devices for selective tripping. 6. Surge protection. Install surge protective devices at the service entrance and at individual RV sites. 7. Wiring methods. Use underground wiring for distribution circuits. Protect conductors from abrasion and corrosion. 8. Electrical pedestals. Choose electrical pedestals designed for RV park applications. Ensure pedestals are weatherproof, durable, and equipped with the appropriate receptacles. 9. Metering. Consider installing individual meters for each RV site for accurate measurement of electricity consumption. 10. Signage. Provide clear and conspicuous signage to identify electrical equipment and warn of potential hazards. 11. Emergency disconnects. Install emergency disconnects at strategic locations for quick de-energization in emergencies. 12. Regular inspection and maintenance. Implement a routine inspection and maintenance program to identify and address potential issues. 13. Documentation. Maintain accurate records of all electrical work. Keep wiring diagrams, inspection reports, and maintenance records readily accessible. 14. Training. Provide training to park staff on basic electrical safety. Teach them how to identify potential hazards and respond to emergencies. 15. Stay updated. Stay informed about changes to electrical codes and standards. Update the electrical system as necessary to comply with the latest requirements. By following these best practices, RV park owners and operators can create a safe and reliable electrical system for their guests.